Have you ever wondered how a website can just instantly tell you what your house is worth? It's not magic, I promise you. It's this really powerful idea called supervised learning. And today, we're going to pull back the curtain and show you exactly how a machine can learn to make these incredibly accurate predictions. So our whole story kicks off with a question that, let's be honest, millions of people ask every single year. You could be buying, you could be selling, or maybe you're just a little bit curious. It's a huge decision, right? And getting it right really matters. So how do you actually put a price tag on a home? Is it just some gut feeling, a wild guess? Well, it turns out that for both people and for machines, the secret isn't in guessing at all. It's in looking at the past. The answer is hiding right there in the data.
And this is where we find all the clues. See, in a simple table like this, we've got a whole history of houses that have already sold. We can see all their features, the size, how many bedrooms, the zip code, and most importantly, we know the exact price they sold for. This history right here, this is our treasure map.
Okay, but to teach a machine, we can't just throw this map at it and, hope for the best. We've actually got to prepare it. We need to turn all this raw data into a proper study guide for our little digital student. And that study guide is built on this really critical concept called labeled data. Honestly, the best way to think about it is like a deck of flashcards for the machine. On one side of the card, you've got the question, all the features of the house. And on the other side, you've got the answer, what it actually sold for. We already know the correct answer for every single example.
So in our dataset, the price is the label. That's the known answer for every house. And providing this answer key, well, that's the whole game. It's how we supervise the machine's learning. We're basically telling it, hey, for these features, this is the right answer. Now your job is to go figure out the pattern.
All right, our data is prepped, our student is ready, it is time for the training montage. That's the part where the machine actually digs into our data and starts to learn.
A student can't really learn without a clear goal, right? So we give the machine a very specific one. Don't just look at the data. I want you to learn the hidden relationship between a house's features and its final price. Now, don't let this little bit of code scare you. This single line, it's pretty much just the start studying command. All we're doing is telling our model, hey, take all of these house features, which we're calling X-train, and learn how they connect to all of the final prices, which we call Y-train. Ready? Go. So what's actually happening when the machine gets that command? Well, it's doing two big things. First, it goes through and analyzes all the features for every single house. Then, it gets to work finding the mathematical relationship, that hidden pattern that connects all those features to the final price. It's figuring out things like, okay, how much is an extra bedroom usually worth? So after all that studying, it is time for the final exam. We are going to give our model a brand new house, one it has never ever seen before, and we're going to ask it for a prediction. And this next line of code, this is us handing the exam over to the model. We're basically saying, okay, you're all trained up. Here are the features of a totally new house, our X_test. Based on every pattern you just learned, what do you think the price is going to be? Under the hood, a simple model like this is basically trying to draw one straight line that best fits all those historical data points it studied. It's learning the trend that, as the square footage goes up, the price generally goes up too, and it's calculating the exact slope of that trend. And there it is. Based on all those patterns it found in thousands of previous sales, the machine predicts a price for our new unseen house. It took the features we gave it, applied the logic it learned, and bam! It gives us a specific, data-driven estimate. So let's just pause for a second and zoom out. What we just walked through, from getting the data ready all the way to this final number, it has a name. And it's the secret behind so much of the smart technology we use every single day.
This entire process is called supervised learning. We use labeled data, our old sales with the prices we already knew, to train a model. And the whole point of that training was to get it ready to make predictions on new, future data. That's the whole thing in a nutshell.
So let's just recap those fundamental steps really quick. First, you start with a clear question, like, what's this house worth? Then you grab historical data that already has the answers, your labels. Then you train a model to find the patterns in that data. And finally, you use that trained model to make predictions on totally new stuff. It's a really powerful and repeatable process. And that kind of brings us to our final thought here. We used house prices as our example, but you can use this method for so much more. Predicting stock prices, identifying spam emails, even helping to diagnose diseases. Really, if you have a clear question and a good history of labeled data, what could you teach a machine to predict next?